Hello, welcome back. In the last video, we introduced throttling in Django REST framework. We talk about how you can configure request throttling in Django REST framework. So we have in Django REST framework, we do have a global configuration when you want to set up a configuration that will affect all the views. We demonstrate that not only we can configure the global scope throttling, but we can also apply the view scope throttling as we did in premium. So in premium view sets, we import the scope rate throttle and then created a customized scope premium, which can only affect the premium vset. And to recap, let's issue some requests to premium so we can see how this request is being throttled, how this endpoint is being throttled using the scope premium. We can curl to premium, curl x verb gets http localhost 8000 premium / premium. The connection refused. We need to run the server. Let's run the server 8001. Server is running. Let's go back. How about we create a variable named host equal localhost 8001, and we can curl to 8001 gets http host / premium. You can go on the next line. Header, you can pass our header. Accept application JSON. We know we're getting application JSON. Index your response with for tab. And so it's now found. Let's see the request again. HTTP premium. It should be premiums 1. That's the first request. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 with throttle. The request has been throttled. That's what we demonstrate in the last video. Today we are going to talk about what's gonna happen when the user or the requester issue a request using the X forwarded for header. How Django handle the X forwarded for, and what's happened when Django defaults to the remote address. So as I say in the previous video, every time your request is being throttled in Django REST framework, when the user issue a request, if the request has one of the header, the X forwarded for, let me show you on the slide so I can explain that clearly and simply. We will demonstrate in this video how the X forwarded for and the remote address is leverage used by Django REST framework to throttle a request. Mainly, we will look at the different scenario with X forwarded for. As you can see on this particular request, we have a URL service / query parameter name equal crawling. You know, crawling here doesn't have an A. Of course, that's a mistake from me. We have the hostconsulto.com. We have the accept header. We have the remote address, which is optional. Right, if we look at the bottom of this request, we have the X forwarded for with 2 IP. These are the IP where the request is coming from. First, we have the originating requester or clients, and then we have the next one is the IP of the proxy. So we look at in this video how Django detects the last IP of the X forwarded for so it can throttle a request, just in case the client or the originator is changing their IP. Okay, let's go back to the code and demonstrate that. Okay, to demonstrate that, we need to do some testing. We are on premium. We need to test that a request can be throttled. We are going to test our premium, our famous premium. Let's create a new test premium with X forwarded for is throttled. Okay. And what do we need to test? To test throttling here, we kind of need to create a loop of requests. Something like for I in the range of 1 to 14, issue a request. So before we do that, we are going to change the setting, because in the setting here we have a premium can only allow 12 or requests per minute. We need to make sure that the number of the requests issued in the testing will be higher, so we can make sure that these endpoints can be throttled. The premium endpoint can be throttled with more than the expected number of requests. First, we need to make sure that this value 12 per minute will be a constant, because we need to dynamically override that constant in the test. So let's create a constant called premium underscore rates throttle, which gonna be equal to 12 per minute, and we can pass the premium rates throttle here. And now we can override our setting in the test. Before we override the setting in the test, we need to import the overrides decorator. Let's override settings. So that's the name, override settings. We can decorate this test. Let's override setting premium rates throttle equal, let's do 14 requests per minute. Yeah, and this number shouldn't be little. We need to create a constant too. How about we copy this constant name equal to 14 per minute, and we can just pass the premium throttle rates. So we overwrite, and we need to get the number of the requests. The number of requests here is the 14. So we need to extract 14 from the premium rate throttle. To do so, we can just premium rate throttle. We can split that string. We can split that with /, split that with / here, and we get the first elements from the array. When we split the string, it returns a list on the array, and then we get the first element, which gonna be this integer 14. Now we can loop for request in the range of, we need to cast that element because when we get the first or elements from this array, it's gonna be a string, so we need to cast that to integer. We can now issue the request self client get self premium URL. That's all we need for now. When we finish looping through 14 requests, because that's the number, and we can issue another one. At this point, we already know that the request is throttled because it's issue more than expected for this particular endpoint. Now we can issue another request client get self premium, and we can assert response status code equal status 429 too many requests. We need to make sure that this request we throttle if we issue 14 requests simultaneously. Okay, let's go ahead and test. Python manage test premium. Okay, we got an error. Basically, we don't need to test this one premium since we've changed the paradigm here. We are not implementing the list anymore, but we are trying to test everything. So we should do something like a tagging. We can tag so we can specify which one we need to test. Let's tag testing now. So we just need to test this one. The test premium with X forwarded for is throttle. That's the test we're gonna test. So we need to test tag equal testing now. Okay, it looks like we are testing something else. We have a testing now from customer. So let's name this one testing premium, so we can make sense of that. I'm pretty sure we have another testing now at customer now. Okay, let's name that testing premium, testing tag testing premium, so we can confirm that we're testing the correct one. Okay, it's passed. So as you can see, this request has been throttled because we've issued 14 requests per minute instead of 12. How about using the X forwarded? Every time we issue a request here, the request doesn't have the X forwarded header. To check that, we can go to our view so we can print. If we go to our view, let's implement the list and customize that. We can print the request meta. Let's get we can print the request header. Let's print the request header and see what's gonna happen. We can see we don't have any HTTP or any X forwarded header when we issue those requests testing the premium X forwarded. So we can customize, we can add a new header here. We can pass the X HTTP X forwarded for, and let's pass a static IP 192.168.452, something like this. So we pass the X forwarded for. We can copy that and pass that also on the last request. Let's test. Now you can see we do have the X forwarded for automatically that's append in our headers. So as long as the X forwarded for as one IP, this request still gonna pass. It's gonna throttle because what Django is doing is checking on each request if the user as the X forwarded for gets the last IP, and then if the user is logging, combine the IP and the user ID, hash that to the cache lock memory, and on the next request, compare the hash to the amount of requests that's remaining per endpoint, and if the user has, if the user has complete all the requests, this request can be throttled. If not, it can continue. So as you can see, we just have one IP. And what if the user trying to be a little bit smart? What if the user wanna, sort of, creating I call that a layer 7 or layer 4 in TCP IP attack, where the users, they just want to issue multiple requests, by dynamically changing the IP, or there is a met in the middle somewhere that's kind of like overriding this header, in between to issue more requests than the endpoints or the URL can accept. Let's simulate what's gonna happen. Let's simulate what's gonna happen if this IP would be dynamic. To do so, we can just remove the header here. Let's make that dynamic. Let's cut that. We can create a property or the attribute in setup. We call the HTTP config, and this property is gonna be a dictionary. It's gonna be a dictionary, and we want this dictionary to have dynamic IP. And we can make this attributes to be a lambda function. So lambda, when you receive X arguments, pass it dynamically, and therefore we can call this HTTP config as a function by passing a random digits, which gonna be the number of requests, the index of the request, to the power of 2. Right? So when you get this, we automatically change this IP. The IP will not be static, and we just emulating an instance where user is sending multiple requests with different IP. And let's see what the way Django will react. Yeah, so we do have that. What's happening here might be referenced before. So we can make reg 0, just to make sense of that. There is different way to do that, but we do that this way. And on each request, also in the loop, we need to pass this dictionary HTTP config reg to the power of 0. No, let's say to the power of 2, the same. And we see how the IP will automatically change here. So the request, instead of having a constant IP, each request will have a dynamic IP. And this, by no means, I'm not a security expert. I'm not trying to teach any security class here. I'm just demonstrating by analyzing and exploring different options, the way Django handle throttling a request. So we have that, and we accept this one to return. It's gonna return a dictionary with a dynamic IP. So this should be a dictionary. Keyword arguments. This should be a keyword arguments. Let's test and see what's gonna happen. We can see the test still pass, but in this time we have multiple IP. We have a dynamic IP, or the IP are being automatically changed. So the error is not correct. It should be throwing forwarded. It should be the X HTTP forwarded for. So it's not correct. We have to correct that. Let's test again. Let's see what's gonna happen. Now, this is interesting. As you can see, this test should have throttled the requests because we are issuing 14 requests per minute instead of 12, instead of the default 12. So it should have throttled the request, but why it's not throttling? Well, it's simple. It's not throttling because we are getting a dynamic IP. Every time we issue a request to Django REST framework, it checks the request and then it creates a cache for this particular request using the IP. And on the next request, he's trying to compare it to the cache, but since the IP is different than the previous IP, it's gonna make it pass. So at this point here, there is no throttling. Why there is no throttling? Because all the requests is being, we're receiving 200 instead of 429. And I'm not saying this one is kind of like a vulnerability in Django. There is no vulnerability here. What I'm saying is that the X forwarded for consider the last IP from the originator and the proxy of the server, because this HTTP header is not automatically. It's pretty rare for a user to set that. It's usually set automatically from your proxy server or from your load balancer. We look at that. So as we can see, the text fail here, the test fail here instead of passing. We get 200 instead of 229. So there is no throttling here. What if we had another IP? Let's assume that this is the IP of the caller, the originating caller, the originating client, and we pass another comma, and now we can use the IP of the proxy server, which is 10, 1, 4, let's say 12. What's gonna happen? Let's test again and see what's gonna happen. Clear. Okay, I told Django will only consider the last IP because this is the IP of the proxy. Let me show you one architecture, to demonstrate how this can be possible. Let's look at this architecture. And this is a Kubernetes architecture. By no means this architecture can be perfect, but this is one of the design that I did probably in 2019. There is this company they were trying to, asking me to design for them some, kind of like making sure that I understand Kubernetes. Look at this architecture. We have a different replica sets, Kubernetes replica set, and this video is not for Kubernetes. If you don't have knowledge about Kubernetes, there are plenty of documentation online. You can look at that and understand Kubernetes. But the point of this demonstration of this architecture is that we can see we have a jump server for all the requests coming in the network or the virtual private cloud, the VPC. We have the jump server, and the jump server kind of control all the requests and pass it to subsequent pods or subsequent containers. So this is what's gonna happen if you wanna the majority of system that respect security, they do not allow clients to automatically hit their server with the request, just like a client issue a request to application and then automatically direct to where the application is running. They're usually passed up through a jump server, and the jump server can have a configuration for firewall and configuration for filtering and different proxy configuration. And that's what's gonna happen if you have a proxy server or a jump server that control all the requests. Even if the user issue multiple requests with a different IP, your server that depend on the jump server, where the proxy kind of like redirect all the requests, will only pass the IP of the jump server instead of passing the IP of the originated IP from the clients. And that's the way some of the application, some of the system are designed. They're designed to receive a request from the jump server. Okay, let's go back to the code and continue testing the HTTPX forwarded for header. Okay, as we can see, we get 200 because it's not throttling, it's still getting this dynamic IP. Even if we have two IP, we have the IP of the originator and we have the IP of the proxy server, but it's still considering the IP of the originator. Why? There is another configuration we need to set up here on the REST framework. The way Django set it up is that every time you issue a request, if your request has the X forwarded form, Django will make sure that you've set the number proxy. Let's say we have a 3 proxy. If we have 3 proxy, we have to set the number proxy so that Django can consider the last IP. So for this instance, if we have 2 IP, there is an assumption that we have only 1 proxy, and our proxy is 10.1.4.12. To do that, to tell Django that, hey, every time you see X forward, make sure that we're using proxy. If not, use the default IP. We need to set a new configuration here, and that property name is num proxy, which is number proxy, and we have 1 proxy. Yeah, we have 1 proxy. This is our proxy. If we had more proxy, we're gonna set, let's say we have another IP here. In that case, we have 2 proxy because the request first goes to the first one and the second one. So we're gonna use 1 proxy, number proxy, which is num proxy 1. And then let's test and see what's gonna happen if we set the number proxy. Okay, let's see what's happened. Now, this request can throttle. We are getting a 429 too many requests. Why? Because Django is only considering the last IP, since we instruct him that, hey, we have a proxy, we'll be using a proxy and we need only one proxy. We have 1 proxy, and Django understand, oh, now that we have 1 proxy, I don't need this dynamic IP, I only need the last one. And we can see our request is being throttled. That's the way we can use the HTTP forwarded form. And if we don't have the HTTP forward for Django, we default to the remote address. To demonstrate that, we can remove the self config. Let's remove that. HTTP config, and if we go to our view, we go to meta and we get the remote address. Get the remote address, and we can continue testing. There we go. So if we don't use the X forwarded for Django, we default to the remote address header. And that's pretty much what we can demonstrate about the X forwarded for. So the X forwarded for is usually set automatically from the proxy server, but a client can also set that manually, which is kind of dangerous. It also exposes the IP of the client, so it's used with some, with a lot of care, but it really doesn't matter if you are using this header with your proxy configuration. There is no issue about that. Okay, next, next one, we need to create a customized throttle class. So in the previous video, we used the scope rate throttle class, which is the default from throttling package. As you can see, this class is throttling all the verbs. So this is what I wanted to say. Okay, I wanted to say we have both gates, delete, post, and get throttle for this request. What if we want to create a customized scope rate throttle that can only throttle requests if we are using post? Let's create a customized, throttle request, a customized throttle rate class. Should I have said? To do that, we can create a new package here. Name. Let's create a new Python package named Throttling. Yeah. We can start tracking for this package. Let's create a new class. We name that premium scope throttling. Premium scope throttling. Yeah, premium scope throttle. Yeah, to just scope rate throttle. Yeah, that would make sense. That's the name of. That will be the name of the file. Let's add that. Create the class called premium scope rates throttling. This will implement the default scope from REST framework throttling imports scope rate throttle class. This will inherit from scope rate throttle. The main implementation method here is the allow request. If you just pass allow request return to true, it means there will be no throttle. You're just gonna pass every request, but we don't want to do that. We're gonna create some logic here. Before we do, we need to initialize. Since we are implementing the allow request, we need to make sure that the init is applied. Super premium rate throttle set init. Okay. We also need to define a property. You can call this property anything, but let's just copy down the way Django used the scope attributes. And throttle scope, which means that this scope attributes has to have a value of throttle scope. Now we need to set the scope. The scope is coming for scope rate throttle. It still have a property called an attribute called scope. Yeah, so get attribute in every view in get attributes self scope attributes, which is scope throttle. If not, return none. So if self scope is none, return true, which means if we don't find throttle scope in our view, if we don't find the property throttle scope, the request will be allowed. There will be no throttle. We return true. Or we don't want to throttle if it's gates. If we are using the verb gates, we're not gonna throttle. So if self scope and request and the request method in gates. Let's say gates, you know, we could use something like a request method equal get, you know, or but we can use get and delete. Gets if for request method in this array gets and delete. So if we get or if the method is get or delete, we also need to pass. We don't need to throttle this endpoint. If not, we need to set the rates. The rates will come from you know, the parents method gets rates, and of course we need also to set the number of requests, and the duration, which is a deconstruct from self parse rates, which takes the rates as an argument. That's all we need, and then when we're done, we can implement the parents premium scope rolling self allow request. Then we call that using the request and the view. That's all we need to create a customized scope rate throttle class. Of course, it's up to you to define your own logic. In this instance, our logic is just to restrict get and delete. If we allow get and delete, there is no throttling on get and delete. You know, what is true is in real world scenario, you wouldn't allow get not to be throttled because it might be dangerous. But we just want to demonstrate the way you can customize. It's not really dangerous, it depends on the scenario, but we just demonstrating how you can use a customized scope rate throttle. Okay, let's implement that. Let's go back to view. Now, instead of using the default scope rate throttle, we can use our customize now. From premium throttling on class on file premium scope rates, imports premium scope rates throttling. You can pass that here. Now let's try to test and see what's gonna happen. We can use the code directly, you know, just use code directly. By using the curl command, we have to type 1 and 2. We can just use a bash script. Let's create a bash script file. Touch some, I'll call that some requests, sudo nano request. Okay, shebang bin bash shebang say no to the. Okay, we have to create a loop here by issuing more than 12 requests. Remember, in the setting, we need 12 requests per minute. So let's create a loop here for, you know, I in let's say the range of 1 to 14. Do curl x verb and create our variable here, host equal local host 8000, and we need to get http host premium/premium I'm pretty sure it's premium. Yeah. Okay, let's try premiums. Premiums. And go on the next line. Header. Accept. Application. Guessing. Indents. For done. But before we get done, we need to make sure that after each request, we can just, leave an empty line. That's all we need. Let's exit list some requests. We can execute that. We need to add the execution permission, change mode, plus execute some requests. Now, if we list execute, it's not going to be executed. So we could now resolve the host. Sudo nano some requests. We can resolve the host, which means we need to pass this as a variable. Yeah. Let's try again. Connection refuse. It looks like it's not running. Oh, we need 1001. So let's go back. The post should be 1001. Request. There we go. Now, as you can see, we issue 14 requests without getting a thorough request. Why? Why are we not getting a thorough request? Because we've instructed the premium scope rate throttling class to skip get and delete. So if there is get and delete verb, just allow this request. But what if we want to try the post? Let's try the post and see what's going to happen. To do that, we need to go back to the testing. And guys, I'm sorry this video is getting long, but I'm kind of like in the rhythm of demonstrating different scenario of throttling, and it's better for me to share this, you never know, somebody will need it. Okay, now test post premium should be throttled. Again, we use the same logic. We need to customize or override the setting. Premium rate throttle equal premium rate throttle, which is gonna be 14. Yeah. Now we need to issue some requests. Number of the requests equal to self premium throttle rate split star with / get the first element for requests in the range of cast number of requests to int self client. Now we need to post. We're gonna post instead of getting. So what are we gonna post? We need a payload. Payload. We need price for the premium. Let's look at the model for premium. We have price, payment cycle, and policy. Price, which is a small integer. A small integer is just a couple, I mean, it's just 1,000 of, we only gonna accept 1,000 we only gonna accept 1,000 for the small integer. And we have the payment cycle. Let's make that monthly string monthly. And we have the policy. Let's say policy gonna be ID number 1. We're gonna post at self premium URL. Payload is gonna be payload. We don't need any we don't need to customize the header. We're just gonna use the default header so we can get the remote address IP. Next, we need to capture now the response, assuming that this one will throttle. Let's issue another request. Client post self premium payload, and we need to assert the response. Assert equal response. That is code. It should throttle, so the static code should be 429. We can now test our request. Python manage tag. Let's use this tag. Copy. We can cut that. Tag equal testing premium. Manage by test. We need to use the test. Okay, it looks like it's passed, which is not correct. It shouldn't be passing. Let's try something. Print response content. Looks like it's working. You should throttle that. It makes sense here. What am I talking about? You should throttle that. Let's comment this one. Comment that. Yeah, so it throttled the pulse, but it didn't throttle the gates. It makes sense. Self pulse response. Print response content. Let's see what's gonna happen. Method is not allowed, so it's not working. The pulse method is not allowed. Why is not allowed? Because even if we're expecting post here, because post is not on the list, but we didn't implement post for the premium endpoint, so we need to correct that. We're only using gates and list. Post, we use create. Yeah. Let's test again. Premium test. You know about testing is that sometimes it looks like it's working, but if you test it and you really test it well, then you discover that it's not really working. And that's what's really fun about this job, is that you have to test something, get to fail, get up, try it again, and make sure it's really working. We got a new error here. We got policy invalid primary key 1. So we want to create a new premium, but we're passing the policy ID that doesn't exist. So we need to create a policy. We can use this method where everybody use, where they can create a new, like a new class on each case. I like to use the function setup test data. which is a method class. Class method. It's a class method, and we create our policy here. Policy, because policy doesn't exist in the test. Policy objects creates. We need to import policy from policy matters. Imports policy. So we're gonna create policy here. What does policy needs? Let's look at policy model attributes. We need the name, the face value, the deductible, the type. The creator is automatic. Let's go back. Name, we call that save more. You know what insurance company tell you, like save more. That's the name of the policy. Save more with Santa. No, I don't like that name. Save more with whatever. Mr. Bean. Okay, that's the name of the policy. The face value. The face value will be, let's say, 45K. What else we need for insurance? The deductible. Since we have 40,000K, let's make the deductible 1,500. And the last one, but the least, is the type of the insurance. Let's say the type will be auto. It's an auto insurance. So we create our policy. Now we can use that because it's gonna have the ID, the default ID of 1. Let's use that and test. Okay, now we can create a policy. Cool. Now that we can create a policy, let's go back with testing throttling and make sure it's gonna throttle. Oh, by the way, in the previous steps where we test without effectively creating a new premium and it passed, it did pass because as long as we're using pause, which is now in the list of the verb we should skip, it still allowed. It was able, even if the post was failing, it was able to get that passed. So, but we didn't effectively creating post. Now let's test again. Now the request has been throttled, and this is the effective throttling because it's effectively creating. And when the maximum number of requests is reached, it's throttling because we're issuing 14. Okay, guys, I think I have to stop here because this video has gone so long. We've taken a lot of time, but the purpose of video was to demonstrate how you can use the X forwarded for in Django REST framework to throttle your requests, how Django REST framework effectively leverage the HTTP header X forwarded for versus the remote address. We also demonstrate how you can create your customized scope rate throttling or any rate throttling class, so you can throttle your requests with different logic. In my case, I use the logic of skipping the verb get and delete. Let's finish this test to make sure it's passing. Self assert equal response status code to status dot HTTP 29. There we go. Okay, that's all we got. Thank you for sticking around, watching this long video. But I think it might help somebody out there trying to understand how the red throttling works in Django REST framework, and I also demonstrate that by doing a bunch of tests so you can know. And of course, the idea here is that a malicious user with bad intention, they can issue different requests by modifying the X-forwarded header with bunch of IP so they can skip throttling. But Django has provisioned that by capturing the last IP only if you precise the number of proxy. Thank you for watching. I will see you in the next one.